Hi there, welcome to my channel. In this video, I'm going to discuss about the solution for finding bitwise and of numbers range. Let's look at the problem description. We are given two integers left and right that represents the range starting from the number left and then the right. We have to return the bitwise and of all the numbers in that range. Let's take a look at the example 1. Left is 5 and the right is 7. The output is 4. Bitwise AND of 5, 6 and 7 is equal to the value 4. In the case of example 2, the left and right both are 0, so the output will be 0. And in the case of example 3, the left is equal to the smallest number in the 32-bit value and the right is equal to the largest number in the 32-bit value. So for that, the AND of all the numbers will be 0. So the constraints are the left and right values are ranging from value 0 to 2 to the power 31 minus 1. We are given the input, the variable left equal to 9 and the right equal to 11, and the expected output is 8. Okay. So if we look at the binary representation of the values ranging from 9 to 11 will be 1001, 1010, 1011. Okay. If we AND all these three numbers, so if we start from the least significant bit, AND of 101 will be 0, AND of 01, 1 will be 0, and AND of 0, 0, 0 will be 0, and AND of 111 will be 1. Okay, so the final value is 8. Okay, so if you look at it, we have to find the common prefix in all the numbers in the given range. Okay, and we have to return that value of the common prefix. So how can we find the common prefix? Basically, we can do a bit manipulation on the value right until value of the right variable become less than the left variable. Okay, for example, if you see here, we have the starting number for that range is 9 and the ending number is 11. Okay, so first we reset this bit, okay, and update the right variable. So what we get 1010, that is 10. Okay, next we clear the first bit that is set from the least significant bit, and what do we get? We get 10008. Okay, but now the value of right variable is less than the left variable, so we can return this value as the bitwise AND of all the numbers between the 9 to 11. That's what I have written here. So if the left is less than right, then clear the first bit that is set from the least significant bit in the right variable and then assign the new value to the right, and repeat the above step until the left is greater than the right variable. Okay, once we come out of the loop, then return the right variable as the bitwise AND of the range. Let's look at the flowchart. Input for this procedure is values left and right, which is the starting and ending numbers of the range. And in this for loop, each iteration we check whether the left is less than right. If that is true, then we clear the first bit that is set from the least significant bit in the right variable. Okay, and then assign the new value to the right. Okay, so if we do and the right with the value right minus 1, then we clear the first bit that is set from the least significant bit. Okay, so we repeat this until the left is greater than right. Okay, once left is greater than right, then we come out of the loop and return the right as the bitwise AND of all the numbers in the range. Let's move on to coding. First I write the for loop. Here I check whether the value left is less than right. If that is true, then I update the right variable. We clear the first bit that is set from the least significant bit in the right variable and update the right variable. And then finally I return the value of the right variable. Next I'm going to run the test cases. All the tests passed. Next I'm going to submit this program. Cool, this program is accepted. Next I'm going to do the code walkthrough with sample input. We are given the input range. Left value is 9 and the right value is 11 and the expected output is 8. Okay. So the binary representation of left is 1001 and the right is 1011. Okay. In this for loop we check whether the left is less than right. So in the iteration 0, left is 9, right is 11. So we go ahead and clear this bit from 1 to 0. So after clearing this least significant bit, we get value 10. So the 10 is assigned to right variable. So the right value of the right is changed from 11 to 10. And in the iteration 1, we clear the second least significant bit. Okay. So it changes from 1 to 0. So now the right value is 8. It's changed from 10 to 8. So now we compare these two values. So now left is greater than the right. So we break out of this loop and return the value in the right variable, which is 8. That is an expected output. Next I'm going to do the time and space complexity analysis for this solution. Time complexity of this procedure is order of 1 because regardless of input range value, the maximum number of iterations this for loop perform will be 31. So let's take the case 1 where the range is from 0 to 1. There is only 2 numbers in this range. So in this case this for loop performs only 1 iteration. In the case of 2 where the range starting from the smallest number in the integer and the right is the largest value in the 32-bit integer. Okay. So in this case the maximum number of iterations this for loop perform is 31. Okay. So that's why the time complexity of this procedure is order of 1. Space complexity is order of 1 because we are not allocating any additional space. That's why the space complexity is order of 1. Thanks for watching this video. Have a great day.